And how cool is that? We got a robot base. We made a part. We got a whole assembly here with drilling and tapping and gluing. Today's episode is made possible through the support of Jessica and dozens of other people just like you. If you like robots and electronics and exploring science and technology and you want to be a part of all this, check out the links below in the description and see how you can get involved. Thanks! Hi there guys, I'm Boden and welcome back to the workshop where today, finally we get to start building Project Archie. We're building a robot and I am more than a little bit excited about this. We're going to build an Anon Robotics AR3 soup to nuts, step by step, right here in the shop, largely on this bench. And I am just over the moon excited about this. We're going to do it by the book, one step at a time, and we're going to make a massive series of videos taking you step by step through how to do this. This, straight up nerd porn. Like that just, we're not going to get a million hits on this. We're not going to get a lot of people even interested in watching most of these videos, but we're going to make a robot, and we're making a robot, okay? Like from scratch. This isn't like we sent tens of thousands of dollars off to KUKA or ABB or something like that. We're doing this like 3D printed pieces, okay? 3D printed pieces and a lot of CNC aluminum. So today we start with the base and we're going to build from there. We're going to learn a lot of skills along the way, and I'm really going to take the time to take you through stuff. Like today we're going to learn about drilling and tapping, which is going to be kind of cool. So with that, let's build a base. So first thing you do is you got to have your parts. Now these are 3D printed. I made them here on Creality CR10S, and nothing terribly difficult. The only complaint I got, if you just download and print this part, the back of the base, it tries to print it upside down, which is great until it gets to doing this. Then it goes tits up in a hurry. But if you're smarter than me, which is a very low bar, and you actually pay attention when you're running it through Cura, which is what I use for slicing, it's pretty obvious. Hey, idiot, it's upside down. So you got to print it right side up like that. As long as you do that, you're fine. But the native file tries to print it like that, and there's an overhang, and it just goes to hell in a hurry. So the other piece, really simple. The thing to note, tab A goes in slot B. And you're going to have to epoxy that. And that's exactly what we're going to do. We're going to do this after we do the drilling and the tapping, though, because I don't want to have to fight the goop. So what we're going to do today is we're going to talk about drilling and tapping, because you got to drill and tap these holes. And you got to epoxy this so it all sticks together. So let's get to work. To drill and tap, nothing to it. People have been doing this for 100 years. All right, so you're going to need an M4 tap and an appropriate drill bit. Now, I have, specifically as I got into this job, I realized that I didn't have a lot of the oddball sized drill bits. And you don't have to be, like, we're drilling and tapping in 3D printed PLA. This ain't rocket surgery. So, to note, there's a relatively wide tolerance with this as drilling and tapping goes. Like if you're doing stainless, you got to be like right on. But you know, we're not playing with Inconel here. So what it did is I measured out my drill bit. Now if you're in America, this is a number 30 drill bit at 127.5 thou, and that's close enough. Okay. This is an M4 metric tap, and here we'll go over to the European standard, and we're at 3.23 millimeters for our drill. Now, when I went over to the store to get it, they didn't exactly have a wide selection of taps, so I ended up with a bottoming tap. Now, a bottoming tap is a little bit more of a pain in the butt. This is designed to thread all the way to the bottom of a hole. Not exactly the tap that I wanted for this, but I think we can make it work. So I got a number 30 drill bit because I just went through my big collection. I've got one of the cheap Harbor Freight garbage Chinesium sets, which are just about all you need for drilling in PLA. I think this is actually something appropriate for my cheap Chinesium drill bits. And we're just going to chuck that up. So when you're drilling and tapping a hole, we're lucky here. We actually have a really cool advantage because the hole is already there. It's printed in the thing. It's just a little bit too small, which is really good, because if it was a little bit too big, it's a monumental pain in the butt to make it smaller. You can do it, can be done, but it sucks pretty bad. So this is our 3D printed hole, which is basically a pilot hole. Lets us know right where to be. Now for drilling it, we're going to go, and you could do this, you should do this, with like a vise and have it all perfect and good. What I'm going to do is just hang it over the edge of the bench a little bit, because I try to, as a rule, avoid drilling holes on my workbench. That doesn't mean I don't, but I try to avoid that. Hold your drill nice and straight, and just chase that hole out, and now we've embiggened the hole a little bit. Tapping, same thing, super easy. I recommend a tap handle. It's like a little tiny drill chuck, except it has a square end, because taps have square ends because you want to get a good positive grip on them. You just put that in there and tighten it. And this is by no means a fancy or expensive tap handle. You can move the thing around, and you can even put, you can see it's got an end on it for a socket wrench, 3/8 socket. But for what I'm doing, this is fine. It's got little ball T-tents. We learned about ball detents in the video the other day. So the big thing with tapping is you have to, absolutely have to have this perpendicular to the hole. You don't want to have any weeble wobble out to the side. That's really bad. You want to have it dead on straight to the hole, which is a little hard when you're first starting it, and particularly hard with a bottoming tap. Don't get a bottoming tap. You don't need a bottoming tap. But get it lined up nice and straight and go in gently and consistently. You don't really have to worry about chip breaking with plastic so much. Also helps if you go in the right hole. So take your time and really get that lined up. And when you're starting, look at it straight on and then get 90 degrees off and make sure, because you can be perfectly vertical here, and then from this side you're kitty wampus. So take your time, get it right. I'm just going to run that in easy. Oh yeah, it's working great. And then once you're started, you can kind of, take your time. It's gonna be threaded for a very long time, but you only get one shot to get it right. And in this case, if you get it wrong, you gotta 3D print a whole new part, which isn't so bad, but it takes time. And then once it's in there, like I'm in 1/4 inch, you can mess with it. So you go in a turn or two, and then back it out. Now this is going to be kind of gungy because it's fine threads. And there's a lot of chip formation because I didn't use the exact right drill bit, which, if you're going to screw around with stuff, you got to be ready to be flexible in how you make it happen. We just run it, and you just let it do the work. You're just turning, you're not pushing. Don't push. And if it feels weird, if it doesn't feel right, back it out. Clean your chips off, which we're probably going to have to do a couple times. And really the easy way to do this. So the best way to do this, just get an air gun and just blow that out from time to time as you go, and then just run it back in, because you'll see it's forming chips. Not really chips so much as shavings. Swarf. And tapping is an arty kind of thing because it goes a lot by feel. And if it doesn't feel right, with metal, if it doesn't feel right, you're going to break the tap, which is the thing to avoid at all costs when you're tapping. Because if you break the tap, you're going to have a bad day. Yeah, we're making a lot of swarf. And the cool thing is this is drilled through hole, so I can put the air gun on the back and just blast that right out like it never happened. And then clean off your tap. Now, the rules of tapping metal are different because you need a lot of lubrication and stuff like that. With plastic, it's much, much more forgiving. Now, we've come out of the hole, so when we put it back in, we got to be careful to make sure that we catch the hole. So really, fingertip pressure. And then once you're in, you'll know, you'll feel it. And now we're tapping already cut threads, which is called chasing. We're chasing those threads. And we get all the way down to where we start cutting again. Okay, and you can feel the resistance pick up. And now we're cutting more threads. So you don't just cut them all at once. If you're doing this in like an 1/8" thick piece of plastic, it's easy. Now look, see, we're starting to make threads on this end. Stuff's falling out. And there's our tap. And we've gone all the way through. Now don't go past where your threads start. Look at that. That's cool. All right, and then we just carefully run that back out. Don't do that all the way to the end. It'll end bad. And support this. See, I'm holding this with a couple fingers because you don't want the very end when the tap comes out, you don't want the tap to fall or get all cockeyed, because if you do, you'll mess up your start. And then it won't be very easy to thread a bolt into it. So very gentle, very supporting. And we have now drilled and tapped a hole. We have created threads. And now if I grab a bolt of the appropriate size, an M4 bolt, I'll go right in there. Look at that. Look at that, we made a thing! Just like that, we made a thing! We have wrought forth from nothing, and we have created a threaded hole, which is really cool. Like, I downloaded a file on the internet from Mr. Annan's website, Annan Robotics, printed it out, ran a piece of sharp metal tubing through it, well, shafting through it, and now I have a functional machine. I have a thing that I can screw a bolt into, and it's in there. And it's solid, and it's good. I made a thing! I know it sounds really simple, but wait until you do this. It's quite awesome. It is pretty much the simplest of things you can make. We made a threaded hole. But the amount of work that went into that, like, some company had to make these. That's a thing. We got to use tools, we got to make stuff. I'm digging it. All right, let's do the other side. Second verse, same as the first. We line it up nice and straight. Don't screw it up. And don't force it. Just, you're pretty much just letting the drill push itself through. Let gravity do the work on that. Clean out the hole. Now I've explained it once, so this time I'm doing it in real time at performance speed. Let's get right down in there. Look at it straight on. Check our, oh yeah, that's close enough. Okay, cool. Could be a little better. Let's make it a little better. Run our tap right on down. And you'll feel it when it starts to resist. You want to back out? Yeah. Tapping is a patient process. Unless you're doing this like in a CNC setup where you got a drawer full of taps you can break as you really get it dialed in to maximize efficiency, and people are paying you lots of money and you got to do 10,000 of the things, and it really matters that you can get 15 seconds off your cycle times. Outside of that, which is a very, very specific workflow, if you're just doing this on your bench at home, you got all day. You got all time in the world. YouTube will let me make videos hours and hours and hours long. We're not in a hurry. Film is cheap. So we're just going to take our time and do it right. I mean, this is a fun project. We're making a robot for fun. What a particularly special level of nerd you are when you're at the I'm building a complicated interdisciplined machine where I gotta know 3D printing and metalwork and plastic work and electrical and electronics and computer programming and kinematics, and I'm gonna spend months doing work just so that I can pick up some blocks on one end of a table and put them down somewhere else very, very accurately. You're a nerd. Accept it. Embrace it. We're making robots for fun. There's people that make lots of money and work very hard to do this. And for a lot of them, they don't have to work as hard as we have to work to do this, because we got to learn all kinds of new stuff. But how cool is that? We get to explore this, we get to learn new stuff, we get to make things. I'm digging it. We're making a robot. One bolt, one piece, one step, one video at a time. All right, we're coming out of there. Very carefully now. Like, I'm holding the tap more than the part, because the tap is heavier than the part. That's going to come right out. Come on. Oh, I hate this part. Because that's the part where like you drop it and it totally borks the threads, and then you're screwed. All right, let's clean this off. Blow out our hole. Blow out our other hole. Okay. We have now drilled and tapped the holes for the base. Let's run a screw into each. Make sure everything's good. Oh, look at that. Fits like it was made for it. That's our M4 20mm bolts that came in our hardware kit. Oh, I love it. All right, there you go. That is so cool. I know it sounds dumb, but it's a thing, man. We made a thing. All right, so now, next piece of our base, we have to epoxy. We have to glue things together. So I'm gonna blow all the shmoo off of that, all the shmoo off of this. Now, this fits pretty close, but not 100%. It's pretty close though. I'm just gonna sand it a little bit, and then we'll smack it with a hammer, and then we'll glue it together, because it has to lay flat. We're gonna want a little bit of sanding in there, because it's not an interference fit. That has to go in there, and a little bit of epoxy, and she's good. So we're going to sand this down just a little bit. They make machines that do this, but I don't need to be that aggressive with it. Yeah, I just want to clean up the edges, and I'm going to take an X-Acto knife. I'm going to take an X-Acto knife to the very bottom here and just clean that, the brim layer on the print. Clean that up a little bit. Don't be afraid to whittle a little bit off. This is on the bottom. Nobody's ever going to see it. And it's better that it fits than that it looks 100% perfect if you're staring at the robot from the bottom, which is going to be bolted down to a table anyway. I really should buy blades that are the right size, you think? Kind of wandering around in there, but that's all I needed. All right, let's sand the other side a bit. Okay, I'll blow that off. All right, so we're all sanded, we're cleaned off. You want to wipe any dust off. Make sure you get rid of little bits. So what we do now is we're going to mix up a little bit of epoxy and we're going to glue these together. Now there are about 1 billion different brands, flavors, colors, viscosities, types of epoxy in the world. Use whatever you like. Use your brand. It's epoxy. Your stick is short and weebly. I prefer mine. Okay, excellent thing for mixing epoxy in for small batches. Just for me, because you want to mix it in something. A lot of people use like a paper plate. That just old electrical tape boxes, the containers they come in. I do a lot of electrical work, so I have a ton of those. Take off your ring and put on some gloves, because we're playing with goop, and lessons have been learned. If it's a tube of epoxy, take off your ring, put on some gloves. If it's a 5-gallon bucket of epoxy, take off your watch and put on a crappy shirt. Probably crappy shoes, because lessons have been learned. So this doesn't have the mixing nozzle or anything like that. We've got 5-minute epoxy, just clear. So I'm just gonna pop off the little cap like that. I love that smell. Yeah, I know that makes me weird. I'm gonna mix out the whole thing. We're not gonna need anywhere near the whole thing, but I'm gonna mix out the whole thing. The thing with mixing any kind of epoxy, mix it until you're absolutely 100% certain it's completely, thoroughly mixed and you are absolutely done, and then you're halfway there. You cannot overmix this. Now you're not going to need anywhere near this whole tube of epoxy, but epoxy is cheap and I didn't want to mess around with it and I just wanted to be certain that we were good to go. So I'll see if I can find something else in the house that needs gluing. All right. So we're going to grab that to set it on when we're done. So here we go. All we got to do, you've mixed the hell out of it. It's mixed. Take a little thing here, and we're going to apply a liberal amount of epoxy. And you'll see I'm not putting it anywhere except on the sides. I'm not putting it on the top or the bottom. Just put a big dollop on the side, put a big dollop on this side. And I'm only putting on one side. And then we just set it down and send it home. Push that all the way in, push that all the way in. Now the big thing, and this is the step that's easy to skip, is I'm going to grab a little hammer and I'm going to make sure each of those bases is flat. Okay, and then I'm going to take it off the bench and set it upside. Oh, I can't. It'll flex. All right, we're going to leave it on the bench. We're actually going to glue this to the bench, and that's okay. Though, could be a little smarter. And I'll set it on this, because that's flat enough. I'll just set it on this box, and we're cool. And then I'm going to clean. I was trying to avoid, as much as possible, getting epoxy on the bench. All right, so there is our finished base. We have glued, well, we have drilled, tapped, and epoxied our base together. And how cool is that? We got a robot base. We made a part. We got a whole assembly here with drilling and tapping and gluing and it's all kinds of cool. So that's our first step. That's our first video. We'll be back in the next one where we actually mount the base to this. Like, we're going to bolt with these bolts. We're going to affix a big aluminum base on this when we come back in the second part. So thank you for hanging out for this particular video. You guys are awesome. I do genuinely appreciate the fact that you're here engaging in this level of just embracing your nerdness, because that makes you cool. You guys are awesome. Thank you for watching. Thank you for hanging out. If you're interested in learning about what I got going on and the video series and all that, check out the links below in the description. You'll find that there's a Discord chat, and you're invited. Everybody's invited. You can be here hanging out live. I got all kinds of guys in here right now. We got Superbrain and Shortwave and Mr. Tuner. People just hanging out, being a part of this, and when the cameras turn off, I'm back to talking to them. So you could be one of the cool kids. Get involved. Be a part of this. Thank you for watching. Thank you for hanging out. I'm Chris Boden. You're not. And that's a robot part. We'll be back next time. See ya. Ooh, the epoxy is warm. Just gonna make a fucking god-awful sound, but we're gonna do it anyway. All right. Fuck. Just, Jesus. God, I need an air reel. Okay. Fuck yeah, robot! Ah.